Huawei launched many distinctive access switches this year. Data at the access layer flows to the core layer of the campus network, where core switches aggregate massive volumes of data of office, production, and operation services. But what makes an industry-leading core switch? Hello everyone, I'm Sam. Today we're honoured to have Mr. Yang Jiayuan, who's a Director of Campus Switch, and also Lars, who's the CTO of Huawei Enterprise Solutions Sales Department, Middle East and Central Asia, with us to take a close look at Huawei's latest core switch, CloudEngine S16700 series switches. Welcome Lars.
Welcome Sam.
And welcome Mr. Yang.
Hi Sam.
As digitalization ramps up, campus networks have a growing number of services, devices, and users, and therefore they have higher bandwidth requirements. Now, Mr. Yang, what changes does the S16700 bring to networks?
Okay, so let's take hospital as an example. So in the hospital networks, if the scan generates 400 images, it's very easy. The speed comes to 1G to all of the images. In the traditional networks, the network is bandwidth insufficient. So the doctors will take a long time to check the images from the scan. It will take a long time for diagnosis. With our new switch, it will be easy to download all of the images. So this year, we launched the new models. We will have two models, that is 16700-4 and 16700-8. -4 with 4 service slot, -8 with 8 service slot. So our new models of 16700 will come to high speed, high performance, and high reliability. So one switch can support 50,000 users. So with one user, 2 terminals, we can support 100,000 terminals. So in the future, we can upgrade the speed to 400G. That means one port can support 400G. As an example, if we download HD movies, just 1 second, we can finish the downloading. So that means our switch can support for the next 10 years as a core switch.
Now that's all really impressive, but what makes that possible?
So to explain that, I need to talk about the architecture of the switch. So we have an innovative multi-level orthogonal cloth design for the switch. That means that in comparison with traditional switches, you have the control board, you have the LPU, you have the SFU, is all connected to a backplane. With our design, we don't have that backplane. So all the cards are directly connected to each other. That means that not only from a speed perspective, and I will talk later on about also airflow, it is a very innovative design. With that, not having the backplane also gives you less attenuation when the high-speed signals are going through the cable. With a traditional board, you have all the cables and you have that attenuation. Since we do not have the backplane, we can get more than 50% additional speed from the platform.
So just as Loris explained, so our platform is very strong. If you need to upgrade the bandwidth speed, you just need change a corresponding line card. So our platform with 16700 can support maximum 14.4P per second with one slot. So our card can support 100G, and it can split to 25G and 10G. So with our line card, 40G also can upgrade to 100G with the RTU license. That means our customer can use 100G speed as 40G price.
And we all know that core network switches, they feature high speed, high density, and also high heat dissipation. Now, heat dissipation is key to the high performance of the S16700. So what are the secrets behind this?
Well, first of all, I already talked about that a little bit. It's the design, right? So the design, if you have no backplane, then you have an open design. Air can flow easily from the front to the back to cool all the cards that are in there. So that is one of the key things that we've done with this design. Secondly, which is also very important for electrical components, that is how do you for the electric components, most of them have a heatsink. The heatsink is essentially just, I would not call it stupid, but it's a simple way of getting the heat out of a chip or another device. So what we have done is we have an innovative technology there that for heat dissipation, that is a solid state at first. If the heat goes higher, it becomes a liquid. If the heat becomes even higher than that, it becomes a vapor. With that, we can cool it down by 19 degrees Celsius to make sure that we don't have overheating in the platforms. Last but not least is also how we have built the fans. So the fans are in a vortex model, so similar like airplane motors. So the suction is much higher than you would get with a normal fan, and that also is being used in the platform, so we can have that additional heat dissipation based on the fans as well.
So without doubt, such performance would not be possible without a powerful power supply. So do we have any unique features in the power supply design?
Yes, it's a good question. So in our new platform, we have the industry unique dual power input. So with the power modules, we have two lines for the input. We have the intelligent switching functions. So if one line is fault, we intelligently switch to another line with just milliseconds. You didn't wear anything, it already changed to another line. Besides this, we also have some new technologies. This new power supply we called compact powerful power module. That means we were 90% higher power supply efficiency, but the space will decrease 50%. So that means if you have 10 power supply, but the efficiency is just like 20 power supplies as before. So with the new power supply, we just need 2 sums space. We can provide 1060 watt with the new power supply modules.
So reliability is crucial to the campus core network. Now, Lars, what achievements have we made in terms of reliability assurance?
That's a good question, Sam. So if you look at the design, what I was talking about, the orthogonal design, that enables us to have a redundancy in the forwarding. So we're using SFUs. We do a N+1 architecture for the SFUs. Secondly, it's also separate from the control. So that means that even if something happens with a control, a failover with control or anything else, there's no impact on the forwarding in the platform. All of the other components, so the main control board, also the SFUs as well, the fans, all of that work in a, let's say, an active standby. So there's always a failover method in the platform for any of the components.
So Lars, you were just telling us about the hardware reliability. So what are we doing in terms of network reliability?
Very, very good question, Sam. So you can have as much as hardware redundancy. If you don't design it well, if you don't have the right protocols on your platforms, then you still have an issue. So take, for example, high precision manufacturing. If anything goes wrong there, even if you do a box upgrade, but you lose network connectivity for some time, that's going to cost a lot of money. So traditional networks, however, are built like that. You don't have that proper redundancy in the network. We tried, but as an example for stacking, there's some issues there. We'll get back to that. What we've done is we've introduced MLAC into our platform. Now, MLAC is a technology where you can essentially use the boxes as a single box, which was, like I said, done with stacking. However, the benefit is that you have separate control platform. So 2 platforms have their own control. Stacking, for instance, it's one control. So if that control goes down, you have an interruption. So with MLAC, I have 2 boxes, 2 platforms. If one platform goes down, no impact. If I need to upgrade one of the platforms, no impact, because from a control perspective, they're 2 separate. So that is where, from a design and from a network perspective, you can have a lot of benefit from MLAC technology, for instance.
And I hear that MLAG can actually achieve reliability of 6 nines.
Yeah, so besides, Larry said, the network reliability is so important. But besides that, the user's quality and use the network experience is also another topic. As a core switch, we will carry a lot of service. So like a bank, we have the email, we have the video conference, we also have the bank transaction service. It's the core service of the bank. So in such kind of customers, we can provide network slicing functions. So we can divide the user's traffic for different services, like I said, emails or core service. So if we use the network slicing for the high quality or low latency and high speed, for this kind of service, we can use network slicing. With these functions, we can guarantee the user's bandwidth, user's latency, and we can guarantee the experience of the service. At the same time, we can also improve the efficiency of the O&M. It will be easy to maintain the service.
And SRv6, I understand Huawei used to only have it on the high-end routers, but now it's available on the switches, which is really impressive.
Yeah, so SRv6 normally as a router functions, but now we can support in the core switch. As we know, the WAN network is provided a line to the enterprise. So core switch like the end of this WAN network. So we can provide SRv6 end-to-end from the WAN to the LAN. So it will be transfer the traffic from the WAN network to the campus network. As a core switch, we also can support these functions.
Mr. Young, Lars, thank you for sharing your thoughts and insights. For sure, digitalization requires future-proof campus core networks with higher bandwidth, as well as larger capacity and more robust reliability. With ultra-large capacity, lightning-fast speed, and ultimate reliability, it's clear that Huawei's S16700 series core switches are ideal for customers to build future-proof, high-quality 10 giga campus networks. So anyway, Lars,